All right, related rates. Okay, what is a related rate? It's, this is all being recorded. Okay, related rates. It's not equal, it's simply you're given a rate of one variable, and using that you have to find the rate of another one. Okay? So, for example, find dA dt in terms of dr dt if A is the area of a circle of radius r. So it's asking for the rate of change of one variable with respect to another one. Okay? Often this will be given as a value, right? And using that you can find the value of dA dt. Okay? But here it's just asking you for a formula, the relationship between them. Now, in order to have any relationship between the derivatives, you better have a relationship between the variables itself. So you first have to figure out the variables relationship, A and R. What's the relationship between the area of a circle and the radius R? A is pi r squared. Okay? And then you just have to differentiate both sides by t. Now, what you have to understand here is that you have to consider both A and R as a function of t. So, for example, if you had a circular black spot of ink that's spreading, okay? Oh no, that's bad. Yeah? But since we're mathematicians, we are more interested in about how fast this area is going to change with respect to the rate of change of R, right? That's the question that we will have to ask. And so both R and A are functions of t because they both change as time progresses. Okay? And therefore, when you're differentiating pi r squared, you have to think of R as a function of t that's nested inside the square function. Okay? So that's why, as long as you keep that in mind, then you realize all you have to use is the chain rule, really. If you know the chain rule, you can solve this. It's that easy. Okay, so let's try this. Let's try to compute the right side. First, pi is a constant multiple. I can pull it out. And then I only have to differentiate r squared. And because this r is a function of t, nested inside the square function, we differentiate r squared as a function of r first. In other words, you differentiate the outside function. But the inside function has to be pulled out, and you have to differentiate it.
So that's what we found. So that's what dA equals then?
Yeah, and actually this is the answer. I mean, if you want to simplify, it's 2 pi r dr dt. So dA dt is 2 pi r dr dt. And as you can see, you've made a relationship between the derivatives. The change of the area is the rate of change of the radius times the 2 pi r, which is the circumference. Circumference times the rate of change of the radius is the rate of change of the area. That's what it says. Let's try a more specific example. What if there's an oil spill? Oh no. a ruptured tanker there's oil in the ruptured tanker and the oil spreads in a circular pattern. If the area of the oil spill increases at a constant rate of 2 meters, so if area of oil spill increases at rate 2 square meters per second, how fast is the radius increasing when radius is 40 meters. So we get to apply this part A to part B. And I mean, many people approach this problem in different ways, but I believe that such questions can be solved in a much understandable way if you use the correct notation for it. A lot of people don't know what to do because they don't know the correct notation for it. So first, I want you to notice that there's this word rate and fast. Speed, rate, fast. What are those things? It's the rate of change, right? How do you write down the rate of change? Rate of change is? What is the rate of change?
2 meters squared.
No. What is the rate of change in general? When you're given a variable, what is its rate of change? Wow, the whole semester was useless. Huh? It's the derivative, right? It's the derivative, right? Yeah, rate of change is the derivative. What did we learn? There are two means of the derivative. One is the slope, the other is the rate of change, okay? So whenever you see this word rate, fast, speed, okay? All these things should be written in terms of the derivative. Got me? Understood? Okay? So this is what we are going to do. Area is increasing at the rate of 2 meters per square second, 2 square meters per second. How do you write this? dA dt, because it's the rate of change of the area. And what is this equal to? This is equal to 2. Okay? That's equal to 2. That's what this first sentence is saying. Okay? And the question is, how fast is the radius increasing when radius is 40 square meters? How do you write that? You write d r dt. You're trying to ask this question. Okay? And here's another way, another notation that you should try to make use of whenever possible. Okay? This word when. When you see this word when, then you're going to write it as when r is equals to 40 meters. Okay? And this is important because so many people just plug in r equals to 40 at the beginning before they differentiate. But once you write it in this format, a bar with this thing, then you know that you should be differentiating first, and then you evaluate the function at the end. That's what should be done. All right? So please, when you do these rate of change questions, always pay attention to the word rate, fast, speed, and you want to write them as derivatives. And then when you see this word when, you want to put a bar with the variable written like that. Okay? If you keep these, I mean, if you always follow these format, then the rate of change is not that hard. Okay? All right. So now let's try to figure this out. Well, usually this question could be just given without this part A. And in that case, you should first figure out its relationship and then differentiate. And once you've differentiated, now you can plug in your R value, okay? Since this is our first question, then I tried to make the question easier by first trying this out and then just plug in everything you need in the equation we got, okay? So if we use this, we have dA dt equals to 2 pi times r, which is 40, and dr dt. Okay? So dr dt, when r is 40, you can solve this and say dr dt is, if you divide, well, 2 cancels. If you divide this to the other side, you get 1 over 40 pi. That's the answer to the first one.